Good evening. My name is Fong Sinian, AN20001X6. I will start the presentation of our lab report with the title Operational Amplifier. Let's start with the project scope. Our project scope conducted to demonstrate the ability to understand and respond to suitability of electronic project. Include research, writing, creating circuit, simulating the circuit using the software like Produce X, mathematically analyze the circuit and compare with simulation result. Our main progress is create a complete circuit with different type of operational amplifier, calculation by simulator and manual, and the result of the circuit. Next is introduction. Operational amplifier op-amps is fundamentally a voltage amplifying device. It is designed to be used with external feedback components such as capacitor and resistor between its input and output terminal. An operational amplifier is a very high gain amplifier having high impedance and low output impedance. A standard op-amps have two inputs which are inverting and non-inverting. In this project, we are using 4 different types of operational amplifier to design and simulate the circuit. The 4 different types, which is non-inverting, inverting, voltage follower, and summary amplifier. Thank you.
A very good afternoon to Pandaila. So I'm Lee Jingwei from Good 6 with matrix number AN200200, and now it's my turn to present about the methodology of our project. So in this project, we are asked to propose an electronic circuits project consisting at least 4 different types of operational amplifier. And before we start our project, we have to do some research for those different types of operational amplifier about each of their functions and character play in the circuit. Then we have to discuss the methods and doing the task divisions for each of the group member to complete our project. So before we start to design our circuits, we have to decide 4 types of operational amplifier used in our circuits. There's inverting operational amplifier, non-inverting operational amplifier, summing operational amplifier, and last is the voltage buffer operational amplifier. And after that, we have to set out the value of all of the DC voltage and the resistor and position of each of the operational amplifier depends on each of their functions. So after we done our circuit designing, we have used Produce X Professionals as our software to construct our circuit. Well, to construct the circuits in Produce X Professional, first we need to launch the Produce software, and then we need to create a new project with default design templates and without PCB layout and front wall project. And then we have to create on the label P, that means the Pitts Davis symbols, and selected 145X operational amplifier and resistor sequentially. Then we have to set out all of the components following the designs and connect all of the components with wire. And lastly, we have to simulate the circuits and post the simulations and record the result values at each of the operational amplifier. And in the end of our projects, we have to compare the calculation results and the simulation results and get the final analysis.
Good afternoon. My name is Lee Jarok with metric number AN200204, and I will be continue on our circuit design for our group project. So this is the hand-draw version of our operational amplifier circuit. Is shown that it consists of 4 operational amplifier, one 2.5 kilo ohm resistor, three 10 kilo ohm resistors, and one 20 kilo ohm resistor, one 50 kilo ohm resistor, and 200 kilo ohm resistor. Also, there are three DC voltage supplies with 5 watt, 6 watt, and 2 watt accordingly. So each of the operational amplifier applied with different functions. Like the upper left side, it is an non-inverting op amp, inverting op amp at the bottom left side, and the middle one is a voltage summing op amp, and the last one here is a voltage buffer. And here is the circuit design in the Proteus software. It is almost the same as the hand-drawn version, but only it is added with the supply voltage for each operational amplifier. Then come to the results and finding. We'll be placing the calculation part and the simulation part side by side for easier comparison. So at the first non-inverting op amp, there is a 5 volt DC supply applied at the non-inverting input combined with two resistors with 10 kilo ohm and 2.5 kilo ohm accordingly. So it produced a gain of 5, then with an output of 25 watt with 1.25 milliampere output current and output power of 31.25 milliwatt. Then for the simulation part, the results of the simulation is almost the same, which it produced an output voltage of 25.01 watt with an input voltage of 5 watt. Then the gain is almost equals to 5, and at the load resistance of it, showing an output current of 1.25 milliampere and output power equals to 31.26 milliwatt. Then for the inverting op amp, is combined with a 10 kilo ohm resistor and a 2 kilo ohm resistor with an input of 6 watt DC. Then it produced a -5 gain, providing an output voltage around -30 watt with -0.6 milliampere output current and an output power of 18 milliwatt. Then the simulation results shows that it has an output voltage of -29.99 watt and an output current of -599.8 microampere and output power up to 17.99 milliwatt at the load. Then comes to the voltage summing op amp. The both output voltage from each op amp previously meet here, and with an additional 2 watt DC voltage input. So it consists of 3 additional resistors with resistance of 20 kilo ohm, 10 kilo ohm, and 50 kilo ohm accordingly. And it produced an output voltage of -85 watt with a gain of -28.33 from the voltage input. Since it is connected to a voltage buffer with a very high input impedance, we assume that the load resistance is almost equals to infinity, which produce an 0 output current and 0 output power. So For the simulation part, the output voltage is around negative 80.5 watt, and it also combined with a voltage buffer too, so it provides an output current around 84.68 nanoampere with an output output power of 7.197 microwatt, which is very small. And lastly, for the output voltage buffer op amp, and it has a unity gain of 1, produce a negative 85 watt output, which is same as the voltage previously input, with an output current of negative 850 microampere and 72.25 milliwatt output power. So the voltage buffer here can act as a isolation for the input source and the output signal, or in that other word, it is another voltage source in this stage. So it is almost the same for the simulation part, where it shows a result of a negative 84.99 watt output voltage and an output current around negative 849.9 microampere, producing an output power of about 72.25 milliwatt. And here is the comparison of each results. Since our voltage supply is in DC mode, it will only be displaying a straight line over the time. So the difference of the final output voltage between the calculated part and the simulation results is equals to 0.01 watt. So the error of percentage is equals to 0.01%, and according to that, we can say that there is almost no difference between the results obtained from the calculation part and the simulation. Hence, our operational amplifier circuit is operating normally without any issues. And then for our discussion in this project, the op-amp circuit is constructed theoretically only. So we did not consider the practical condition in real life. Therefore, if we want to build a circuit for practical use, we should consider the maximum ratings inside the data sheet for each op-amp. Hence, to make sure the input voltage, the input current, and the bias voltage and the bias current does not exceed the maximum ratings. Besides, we should also add in some resistors after each input voltage supply to make sure the input source does not exceed the current flow into the op-amp and cause them to be burned. And additionally, after conducting this project, we have learned that an op-amp is not only used as an amplification for voltage signals, it can be also used to invert the voltage input, just like the function of an inverting op-amp. Also, due to its high input impedance characteristics, it can also act as another voltage source at some ideal stage. For example, a voltage buffer, also known as the voltage follower, has the characteristics of voltage source to isolate the input signal with the output signal. And the most importantly and frequently used op-amp is as a comparator, which is capable of comparing the signals, and they are mostly used in performing the various digital logic operations because of their voltage, in this case produced at the output, is limited. So that's all from me. Thank you.
So good evening. My name is Bang Wei Bin with metric number AN200195. So I will present about the conclusion part of our project. So in a nutshell, as a group of 4 people, we have created an electronic circuit project consisting of 4 different types of op-amp, which is the inverting op-amp, non-inverting op-amp, the voltage follower or buffer, and the summing amplifier. We also have solved the question by discussion and research. After conducting this experiment, we are able to understand the theory of operation of the operational amplifier, also known as the op-amp. Besides that, we also conducted our project successfully by using simulation software Proteus. This is to say that we have obtained the characteristic of input and the output of the op-amp in the circuit. At the end of the examination, after we examine each of the op-amp circuit's characteristics, we are able to demonstrate the ability to understand and respond to the sustainability of electronic project according to the desired application with respect to the important component of lifelong learning. So therefore, this project is environment friendly and it prevents the depletion of natural resources. We were very much thankful for the wonderful cooperation of all the group members. Hope that this experiment and this experience will surely help us in our future and also in shaping our career. That's all from our group presentation. Thank you and have a good day.